my name is Dana Golden. Today we're going to finish up the Environmental Economics Introduction lecture with a look at circular flow and how to add environment into your models. So there's a traditional circular flow diagram that maybe you saw in your introductory macro classes, maybe you saw in Econ 101 even. You have a good market, you have a factored market, households buy from the goods market, and they participate financially in the goods market. Firms buy from the factor market, and then they participate financially in the goods market. So this is how capital, households, and firms interact. And maybe you've seen this like with government and with certain additions. Well, today we're going to talk about environmental circular flow. And, this is a very basic model of like what's missing here is the environment. So actually, every good comes from nature. Every good comes out to nature. So we can make this a lot more complex. And so now you have raw materials come from the natural environment. They go to producers who create goods, which go to consumers, which create residuals. And then these residuals are discharged in the environment. They can also be recycled back to producers. And then consumers create residuals, producers create residuals, and all of this has to be discharged. So now we're thinking about, like, when we produce things, we create results that go back into the environment. And we have to think about how that works. So I want you to, as an exercise to the reader, think about how this can be made more complex. What can we add to this model to make it more realistic and more representative of the actual interplay between the natural environment and the economy? So some equations to describe circular flow model. You have an economic system, which is production and consumption. You have an environmental system, which is renewable and non-renewable resources and waste assimilation. You have an output, and now we have this production model. We've added residuals, we've added natural resources. Now you have labor and you have capital, and then you have natural resources. But now your output is also residual. So now, and that's enough. In our circular flow model, we have added the ability to think about non-renewable resources in a way that you don't have in traditional economic models, because now the resources today are equal to the resources tomorrow minus the extraction. So, and maybe there's some natural generation. Maybe you have some creation of oil, which is very slow, or maybe you have trees which grow very quickly. But regardless, you have now this non-renewable process, and now you have renewable resources. Often this is called land and economics flowing into the circular flow. You also have, when you generate quantity, it creates some sort of waste from output. And then the environmental quality is deteriorated when you create more waste. But also, very nice thing, and this is something you can get into a lot in ecological economics and some environmental economics courses, but a very nice thing about the environment is that there's this natural regenerative quality where the environment can actually, get better on its own some. But what we're doing now is breaking the feedback loop and creating an environment that is going to get worse on its own if we don't do anything to stop climate change. You're going to hear me a lot, just randomly mention that climate change is this very bad thing. It's a bad thing. We need to work on it. You probably saw at some point in your career the production possibilities curve. There's also the environmental production possibilities curve, where you have a trade-off between environmental quality and production of the economy. So you can have a very pristine environment and then never never make anything, and then suddenly you die, and you can have a world where you make, and then you go, make, and then you destroy the entire world. So it's a trade-off determined by technology and social choice. If you shift the curve outward, that means that you become more efficient. Right now, we're shifting the curve inward because we're creating an environment that has less resources and is less well-suited to production. So this is what I mean when I say that we're leaving the world worse for our grandchildren. It's because right now we have a choice between market goods and environmental quality that looks like this. But our grandchildren, if we leave behind a worse environment, because environmental quality works like a capital good in some ways, you shift in the curve, and now they can get less environmental quality and less market goods. They don't have the same choice we do, because we've shifted in the production possibility curve. We want to shift this out. And then now, finally, last thing I'm going to talk about in this lecture is the Ehrlich identity. The Ehrlich identity, known as the IPAT equation, is a formula used to estimate the impact of human activities on the environment. So the equation is impact equals population times affluence times technology. Population is about the number of people. Affluence is about consumption per person. Technology is about the environmental impact per unit of consumption. So this gives you a framework for thinking about, if we increase population and we keep affluence and technology the same, that means there's going to be more environmental impact. But this also thinks about technology can be a mitigating factor. If we improve technology enough, we can grow population, we can grow affluence without having to sacrifice anything. And we can decrease the environmental impact by having better technology. I think a lot of people sell you on the idea that technology is the only solution and that technology can, by itself, fix all of the environmental problems. There will need to be some decrease in affluence to deal with the long-term environmental problems, at least in the short term. So to understand the components, population is about larger populations and the increased demand for resources and waste generation. Affluence is about higher income levels leading to increased consumption. There's a much higher energy use per capita in industrialized nations. There's a reason why it's called power, because it makes you more powerful, more able to do things if you have more electricity. And then technology, it's both a cause and a solution to environmental problems. Fossil fuel power plants, you have more of them, that's bad. Renewable energy, that helps solve the problem. So there's an example in carbon emissions. So the population grows, that increases carbon emissions. If the GDP per capita increases, that increases carbon emissions. If the energy intensity decreases, that decreases carbon emissions, but it's not decreasing enough to offset the increased capacity, the increase in affluence, and so you have a significant increase in CO2 despite efficiency gains. That's really what's going on right now. We're seeing a rise in CO2 emissions, even though technology is getting significantly better. We still haven't hit peak CO2 emissions, unfortunately. And then economics is about trade-offs. How should we think about them? Don't we want the rest of the world to get rich? Don't we want everyone to be able to live like we do here in America? But if that happens, we need to get much better technology. We might need to take a step back. So how do we think about the trade-offs? And how do we think about the distributional effects? There's going to be a lot of what this course is about. I really look forward to being your guide on the journey and walking you through environmental economics. I hope you learn a lot. Looking forward to seeing you next time. I hope you have a great day.